Hey, my name is Andre and welcome to this quick demo of Border0's latest update. Today I'm excited to introduce our new application-aware permissions, a significant enhancement that allows you to manage not only who has access to your resources, but also what level of access they have within your applications. So this means you can now define granular access controls for SSH, databases, Kubernetes, and more, all within a single platform. In this demo, we'll explore how you can set specific permissions for different applications and services. We'll start by looking at SSH access control, limiting access to a specific user and SSH features. Next, we'll move on to a database example, and we'll go over how you can control which users can execute what type of queries on what databases. So, let's dive in and see these powerful new features in action. Before we dive into the new permissions, a quick reminder about what Border0 policies are. Policies allow you to configure who should have access to what resources under what conditions. These conditions are based on three key factors. Who, this refers to the SSO identity or group. When, this specifies the date and time when access is permitted. And where, this defines the location, such as IP address or country. Note that you can extend these conditions further with various of our default integrations, such as PagerDuty or Vanta, or you can bring your own custom API check as well. Once all of these conditions are met, the user is granted a set of permissions that define the type of access they have within the application. Let's start by looking at an SSH-specific permission set. We'll start by looking at a policy that I have for control to my Linux servers. As you can see here, there's SSH access only for user Ubuntu, and that user can have shell access. So let's go ahead and validate that. I'll just SSH like I'm used to as user Ubuntu, and you can see that works great. So that's as expected. But what happens if we try this as user root? Maybe I need root access. That shouldn't work. Let's double check that, and you can indeed see that the shell command tells me that that is not allowed. If we go to the session page here, we can see indeed the most recent session was denied, and it says no policy allowed SSH access for SSH user root. So that worked as expected. So let's go ahead. Maybe I do need root access, so I'm going to update this policy. And go ahead to enable username list. You can see there's only Ubuntu here. We'll add the username root in here. I'll just update this policy. And now I should have access as both user root and Ubuntu and should be able to have shell access. Let's go ahead and validate that. So we'll do the same thing as before. And now you can see that I am indeed logged in as user root to this shell server using SSH. That was pretty easy. Now let's go ahead and try something else. Maybe I'm going to do some port forwarding. So I'm going to do port forwarding to google.com on port 80, and I can validate that by doing a curl to localhost 8080. And you can see the error here. See TCP port forwarding access denied by policy. So let's go back to the session page and validate that. So you can see there's a warning sign there now. You can see the events. You can see I have shell access, but TCP port forwarding to google.com on port 80 was denied. So you can see the detailed logging here as well. Now let's correct that. Maybe I do need this capability. So what we can do is go enable TCP port forwarding. You can enable it for all destination, or you can limit it by particular connections or destinations. So we'll do that. So here I'll add google.com and only to port 80, for example. So let's try that. I'll save that. And that should all be updated in real time. You can see the new policy here. So user root, user Ubuntu have shell access, as well as TCP port forwarding to port 80 on for google.com. So let's try that same port forward again by doing a curl to localhost 8080, and you can see that it's now working, right? So that works now too. We can go ahead and validate that by going to the session log table here. We can see the most recent session. We can see a video replay of the actual shell session, just like before. And in the events table here, we can see all of the events, an SSH session, shell access, as well as the TCP port forwarding to google.com on port 80 is allowed. So lots of visibility and control all in one. Now let's go back to the policy. You may have noticed a few other options that we didn't really look at. So there's a few options. For example, we can enable or disable exec access. If you use this feature, you can even control what type of commands are allowed. Similarly, you can control SFTP access. We already looked at TCP port forwarding. For Kubernetes use cases, you can control if Kubernetes exec is allowed. That gives you access to containers or pods. You have the filtering capabilities by filtering based on namespaces, or even enabling pod selectors. For example, only pods where the key is app and the value is nginx. Similarly, you can control access to Docker containers. So you can see lots of control all in one platform, allowing you to define fine-grained access control and visibility all in one solution. Next up, let's take a look at using Border0 policies to control database access. Here we're looking at a database policy. As you can see, browse to the database tab in the permission settings, and here we can set database specific permissions. For example, here you can see that this particular user will have access to all of the databases. So let's go ahead and validate that. So I'm going to use the Border0 CLI to see what databases I have access to. I'll select one, in this case MySQL database, and I'm connecting to it using the MySQL CLI command. Once I'm in, I'll execute show databases, and notice how I get back a list of databases, including the MySQL database, the books database, etc. I'm going to use books, but remember this for later. There's a few tables in here. Maybe I'm going to do a select star from type just to see what's in this particular table. And you can see there's a few entries in here. Let's go ahead and delete ID 1 because I don't like that. So let's remove that, delete from type where ID equals 1, and we're successful. Right? So we did some work in this database. Now we can go back here and I'll click on sessions and we can see exactly what happened during this session. First of all, I can see it was user Andre at Border0 that connected to this MySQL database, and I can see all of the queries, including this delete statement that we just did. Well, that's great, but really I don't want to have user Andre should not have access to all of these databases and shouldn't have delete permissions. So what I can do here is go to the database tab again in permissions, and first of all I'll change the star to user defined and only give me access to the books database, and maybe only read-only access or selects queries. So I'll update that policy. And we validate that here, and you can see now I have access to the database called books and only read-only access. So that's great. So we'll go ahead and try the same thing. So I'm going to use MySQL again to connect. And maybe we'll start with a show databases again. And notice how in this case I only see the books database, right? So that's already a good feeling. So now I can't see all the other things. I can still see all the tables. Let's do select star from type. ID 1 is gone now because we did that earlier, but maybe let's try ahead and try and delete ID 2. As you can see, that is not allowed because I only have read-only access. So that's great. So this gives me a good sense of safety here. I cannot switch to the MySQL database either. So that's because of these permissions. So we go back to the session log here and we click on the most recent session. You can see there's another session by Andre. We can see exactly all the queries that were being executed, but also the ones that were being denied. So for example, that delete was denied by policy, database access was denied by policy. In this demo, we've seen the power of Border0's new application-aware permissions. We started out by demonstrating SSH access control, where we restricted logins to specific users and controlled what actions they could perform. We then moved on to a database permissions example, setting rules to limit the type of queries the user could execute. These new capabilities allow you to manage access at a very granular level, enhancing security and operational efficiency. With Border0, you can ensure that users have the exact access that they need, nothing more and nothing less. This not only improves security by adhering to the principle of least privilege, but also simplifies access management across your organization. Thank you for watching this demo. To experience the power and flexibility of Border0's new policy language for yourself, sign up for free our fully featured community edition at border0.com. Give it a try and take control of your infrastructure with precision and confidence.